This video is part of an online course of multivariable calculus, and we're going to see how to compute triple integrals in spherical coordinates. So let me start. The goal is to calculate the triple integral of a function of x, y, and z dv over the surface S. Okay, so the first thing we need to do is to transform S in spherical coordinates. Then we're going to transform the integrand, the function f of x, y, and z in spherical coordinates. How do I do these two steps? Well, I'm going to use the fact that x is equal to rho sine phi cosine theta, y is equal to rho sine phi sine theta, and z is equal to rho cosine phi. So for x and y, as you see, for all of them we have rho. For x and y we have sine phi, but for z we have cosine phi. And then for x and y, the formula for the polar coordinates would be what? Cosine theta for x, sine theta for y. So rho sine phi is just basically r and then cosine theta. Rho sine phi sine theta is basically r sine theta, right? This is how we can memorize that. And then what's going on? What should we do for dv? That's the big question. So I'm gonna consider dv. It would be something, the change in rho, change in phi, and change in theta, all the coordinates for the spherical coordinates. Okay, so now to figure out what dv is, or basically to figure out the ratio, what I'm gonna do is to consider, I'm gonna fix rho first. Okay, for fixing the rho, I'm gonna graph a shape, and I'm gonna make it big. So I have this shape in here, x-axis, x-axis, y-axis, and then z-axis. I'm gonna fix rho. Okay, so I'm gonna basically consider sphere, make it big, of radius a. So I'm gonna consider the surface area of sphere of radius a, which is basically rho is equal to a. So just assume that we are fixing rho, and then I'm basically looking at one small piece on the surface area. How do I consider that? I'm gonna graph like, I just want to consider, just to grab some small part of this surface area. I'm basically considering this small part when I fix rho to figure out what is d phi and delta phi and delta theta. I'm just considering this small piece. Okay, so let me make it just in here. So I have this small piece like that. Okay, I'm gonna move this one in here so that I have more space to write. I'm gonna move you. Okay, so now let me consider just this side of it. I just want to find the area of this small piece that I grabbed. Okay, so this side is what? First, I can say that this side in here, which is corresponding to that, is basically the piece of a circle. It's a piece of circle of radius a. It's just because it's a full circle. Okay, so it's piece of a circle of radius rho, which is rho equals to A, and the corresponding angle to that, so the corresponding angle is what? Okay, the corresponding angle to it is just because it's between this circle and the bottom circle like this, the corresponding angle would be delta phi, right? Would be the corresponding angle for this side is delta phi. And based on these two information, okay, this arc in here has the length A delta phi. This is the length of this arc that I have in here. And if I make them very, very small, the pieces, then this side and that side would be the same, right? Approximately. And looking at this side, okay? This side in here is a piece of a circle of radius r. It's piece of circle of radius r. Well, what is that? Let me graph it. I'm gonna move this one a little up so that I have more space to write. Okay, I'm gonna have the circle, okay? On the equator, this circle has radius A. This sphere has radius A. And then if I consider another circle on the surface of the sphere, the radius of this circle, if I call it r, r is less than A. Now let me graph the z-axis. Okay, I just want to think about the way to calculate r. Okay, this angle that I have in here is phi. Okay, so considering the right triangle that I have in here, this right triangle, I can say that r is equal to A, which is this part in here is also A. Okay, the hypotenuse is A, and then sine phi, right? So I can say that this is basically r, and r in here, as I explained, it would be A sine phi. What is the corresponding angle? So the corresponding angle is delta theta. Why? It's just because this side of my piece would be the distance between these two circles. One is like that, the other one is like this, which is basically delta theta, right? And so as you see, I'm gonna move this one to that side so that I can move everything up, and based on that, the length of this side would be equal to A sine phi and then delta theta. Okay, very good. So now consider the area of this small piece. Small surface area of the sphere of radius A is equal to what? Delta S is approximately this side times that side. So this side in here would be A delta phi, and this side in here is a sine phi delta theta, right? So ds, if I make it very small by taking the limit, this one would be what? A square sine phi d theta. Okay, very good. So that's the surface area of the small piece that I get on the surface of a sphere. Now let's see if we have some thickness, right? So for the thickness, what I'm gonna do, I'm gonna graph two concentric spheres. So one sphere like that, one sphere like this, okay? And now let me make it the full sphere so that it makes more sense. Okay, now considering just small, kind of like a shape in the middle, which would be like something like this. So I have a surface area, which is this one, and then I have some thickness like this, okay? So the thickness is just because it's the sphere is going to change from rho 1 to rho 2, so the thickness would be delta rho, and then this area in here would be delta S that we already calculated, right? So dV, the volume, would be the thickness times the surface area. Surface area. The thickness is delta rho, and the surface area we already calculated. It would be A squared sine phi delta rho delta phi delta theta. The phi delta theta. Therefore, dV would be A squared sine phi d rho d phi d theta. And pay attention that on here A would be the radius of the circle, so I'm gonna have, instead of A, I'm gonna have rho, because the sphere is not fixed, right? The sphere has the length, the radius rho. So dV would be rho square sine phi d rho d phi d theta. That's the element of the volume that we need to put inside our triple integral to solve the problem. So let me go over one example. So the example is this: find the volume of the solid that lies above phi equals to pi over 3 and below the sphere rho equals to 4 cosine phi. Okay, so what are all of this? So I'm gonna graph the shape. Okay, so this is y, z. This one is x-axis. Phi equals to pi over 3 is basically a cone, because phi measures the angle from the positive z-axis, so it would be pi over 3, and then theta is free on this, so I'm gonna make it round, because theta can be from 0 to 2 pi over 2 to 2 pi, and then rho can be from 0 to infinity, so I have a cone like this. And now what is this shape in here? Let me see. I'm gonna multiply it by a rho, so I get rho squared, which is x squared plus y squared plus z squared, equals to 4 rho cosine phi is basically z. Okay, now I'm gonna bring negative 4z on the other side, and then I want to make it a perfect square, so I'm gonna multiply, I'm gonna add 4, subtract 4. Okay, so on here I have z minus 2 squared, so I get what? X squared plus y squared plus z minus 2 squared. I'm gonna bring negative 4 on the other side. So it's a sphere with the center 0, 0, 2 and the radius 2, right? So now let me graph the sphere. Oops, I need to move it. And here, let me make it a little smaller so that it fits, because they have intersection, right? The cone and the sphere, right? So I get a sphere. Now I want to find the volume that is above the cone, below the sphere. So this is the part that I want to calculate. I'm gonna call this S. Okay. Now let me show it to you the shape. This is the spherical coordinate. This is rho. This is the coordinate for theta from 0 to 2 pi, and then this is from 0 to pi for phi. Now it's the sphere. I needed to write a parametric equation of the sphere to be able to use the program. So it's a sphere at 0, 0, 2, and now I have the cone. So you see they have intersection. What I need to find is to find the solid that is between these two. Let me make this hollow, and then you see I need to find the volume of this solid. Okay, I hope you can see that is bounded below by the cone, above by the sphere. Okay, so now let's actually calculate that. The volume using the triple integral would be the triple integral of 1 dv over the sphere S. Now let me set up all the bounds in spherical coordinate. I'm gonna move this a little down, and then I have 1. The volume element would be rho square sine phi. Okay, something else, we can write phi like that or phi like this. Both of them are phi. Okay, rho sine phi d rho d phi d theta. Okay, now I'm gonna set up the bounds for rho. So the rho, if I have a ray starting at the origin, it's gonna start at rho equals to 0, and it goes up to the equation of the sphere, which is like that. Rho equals to 4 cosine of phi. Okay, and then d phi. Okay, d phi would be the angle from positive z-axis to the cone, right? So phi would be from 0 to be on the positive z-axis, and then it goes up to equation of the cone. So phi equals to pi over 3. How about theta? Theta is from 0 to 2 pi to make it round, to get the full equation. Perfect. Now I set up the bounds in spherical coordinates, the element, the volume element, and then the integrand, which is also 1. So now let me calculate that. The inner integral in here would be what? I have rho square. Sine phi would be like a constant, so rho square would be rho cubed over 3. Rho is from 0 to 4 cosine phi. So what I have the integral from 0 to 2 pi, 0 to pi over 3. Okay, now let me plug in for cosine phi for rho. Third, then I get 4 to the power of 3, and then cosine phi cube, and then I have sine phi minus 0, right? And then d rho, not d rho because I calculate that, so d phi and then d theta. Okay, perfect. Now to calculate this integral with respect to phi, I said u to be cosine phi, and then du would be negative sine phi d phi, right? So what I have the integral from 0 to 2 pi, okay? And then let me basically write whatever that I have. I have negative sign in here, so negative 64 over 3 for this. And then I get u cubed, and then sine phi d phi would be du, and then the integral of that, I'm not gonna change the bounds, so I remove the bounds, and then later on I'm gonna add the bounds. So this integral in here would be what? It would be negative 64 over 3 times u to the power of 4 over 4. So let me calculate that and basically simplify that. Negative 16 over 3 u to the 4. So it would be the integral still from 0 to 2 pi, and then negative 16 over 3, and then u is cosine phi. I'm gonna replace it with cosine phi to the power of 4, and then phi is from 0 to, what was it, pi over 3, and then don't forget the theta. So theta from 0 to 2 pi, negative 16 over 3. So cosine of pi over 3, what was it? Cosine of pi over 3 is basically 1/2. And so I have 1/2 to the power of 4, which is what? Which is 1 over 16, minus cosine of 0 is basically 1, and then d theta. If I want to simplify this, it is 16, so I get 1 minus 16. These two would be cancelled, so I get negative 15 over negative 3. Negative 15 over negative 3, which would be 5. Okay, so I calculated the integral. It would be 5 theta from 0 to 2 pi, which would be 10 pi. Okay, that's the volume between these two shapes using spherical coordinates.